What we're going to look at is reflection. Now I'm going to be using a raybox, which is simply a light bulb inside a box. When I turn it on, it creates a beam of light. This here is a slit. I can pop that in here to make sure that the ray is nice and narrow. It makes it much more accurate for the experiment. So what we're going to do is look at the law of reflection. To do that, we're going to need a mirror. As you can see, here's a mirror. I'm going to draw a line on the paper to represent the mirror. You can draw it in any angle. I'm going to draw it in this angle. And what we're going to do is on the other side of the line, we're going to draw some hatching. What this represents is a plane surface. A plane surface is a surface that is perfectly smooth and therefore able to form a mirror image when light hits it. I will line up my mirror as good as I can with that pencil line I've just drawn. And now I'm going to shine my ray box at that mirror and we're going to look at what the light does. You can see the light bounces off. So what I'm going to do is make a mark where the light starts, where the light hits the mirror bang in the center, and where the light ends up. And then I can turn off my ray box and I can trace the path of the light. So from the ray box here to the mirrored surface, which is there, and I put an arrow to indicate the direction of the light, and then I draw from the mark on the mirror to where the light ended up. Again, I can draw a little arrow to show the path of the light, shows the direction it's traveling. Now this ray we call the incident ray. That's because this is where the light was occurring. An incident is when something happens. This is where the light was incident. When it bounced off the mirror, we call it the reflected ray. Now what we can do is measure the angle of incidence and the angle of reflection to find out if there is any pattern by using a protractor and lining it up so that the protractor is perfectly in line with the mirror and the crosshairs here is where the light struck the mirror. What we can now do is put a little mark to show where 90 degrees was. So 90 degrees was there. And then we can draw a dotted line. This line is called the normal line. A normal line is a line which is 90 degrees to the surface which your light is striking it, otherwise known as perpendicular. So now we can measure the angle here. So if I line up my protractor nicely, the angle, you can see I've got to get it measured perfectly to the line where the mirror was. So my 90 degree line here is in line with the mirror surface, and I can start counting the angle here. So this angle from there to there is 10, 20, 36 degrees. So the angle of incidence was 36 degrees. I can now flip my protractor over and measure the angle of reflection, which is other side here. Measure my angle of reflection. So I'm going to have to line up my protractor nicely, and then what I need to do is count the angle again. Let's get it measured up perfectly. That wasn't quite in line, was it? So from here to here, we're going to measure that angle. 10, 20, 30, and 6 small lines. So the angle of reflection was 36 degrees to the normal. You may notice something. The angle of incidence seems to be the same as the angle of reflection. Let's try that out again to see if it's true. So here we go again. I've changed the angle. I've redrawn my line. I'm going to make a mark where the light starts, where the light strikes the mirror, where the light ends up. I'm going to take my ray box away, turn it off, and I'm going to join the dots up again. Remeasure them again with our protractor. So again, join the lines up, dot to dot. need to find my normal, which is at 90 degrees to the surface of the mirror. So again, I need to measure this part very carefully, otherwise I'll end up with the wrong measurements. Literally a millimetre out would ruin my results. Put a dot so I can draw my normal, which is my dotted line perpendicular to the surface. Here it is. And I can once again measure my angles. So my angle of incidence, the light ray was travelling down there and bounced off here. I'll line up my protractor with the surface of the mirror again and with the normal. Make sure the normal is lined up nicely there. I can measure my angle, which is 7 degrees. That's a 7-degree angle, counting the little marks there. So the angle of incidence was 7 degrees. Let's check the angle of reflection. Once again, have to get my protractor nicely lined up with the surface of the mirror. And once again, looking carefully, it's 7 degrees across here. So the angle of reflection is also 7 degrees. So what we've seen is, no matter what angle I shine the light at a mirror, if it's a plane surface, the angle of incidence will always have the same angle to the normal as the angle of reflection.